Okay, so in the basketball problem, what was the limit? 100%. Graphically, this makes an horizontal asymptote. So before, the day before, we had looked at vertical asymptotes. Then this is looking at horizontal asymptotes. Did y'all get the tables filled out all right? Okay. So like on number 1, who has a table? Chandler, do you have a table?
Yes.
Okay. What did you?
0.998, 0.99, 0.99933, 0.9995.
What was the last one?
0.9995.
5. Okay. Oh, too many. I don't have enough 9s, do I? 3 9s?
Mm-hmm.
And here's 3 9s too?
Yes.
Okay. Okay. So this is going towards what? 1. Right. So for the horizontal asymptote, y equals 1. We're going to see if there's a pattern between the horizontal asymptote and the equation. Okay. So how about in number 2? What was this one going towards? Okay, let's go ahead. We'll go ahead and write down the table, Jared. What did you have?
0.50275, 0.50037, 0.50092, 0.50069.
Okay. Okay, so it is going towards 0.5, isn't it? All right. And then number 3. Actually, how else could you write 0.5? How could you write it as a fraction? 1/2. Okay. You see anything maybe that might be similar up in the equation?
X over 2x.
Okay, this one right here. What's in front of that x? 1. Okay, so we might be on to something. What about here? What's in front of these x's? 1. 1 divided by 1 is 1. Okay, let's look at this one. Chris, do you have this table? Are you here? Okay.
Negative 1.67, negative 1.668, negative
668 again.
1.668, and negative 1.667.
Okay. And this is going towards, obviously, yeah, repeating, right? And what is that?
5 divided by 3 is
What? What fraction would be like 1 2/3? Negative 1 2/3, which is the same thing as negative 5/3. And look at that. Okay. Now, this isn't always the case, but in these 3, the coefficients in front gave us the horizontal asymptote. And that's mainly because we had x over x here, we had an x on the top, an x on the bottom here, we had x and x here. Now, on this one, we have an x squared in the top and an x in the bottom. Okay, we're not going to get 2 over, we're not going to get 2. Did y'all get y equals 2 for that? No. Okay. This went, what, 2002? Like that?
Yeah.
4002? Did it have a limit? No, it kept going up, so this would be none. There is no horizontal asymptote.
So it just crosses it?
Okay, we're going to see. Let's look at another one. Let's look at 8. Is 8 9 also?
Yeah.
Okay. Well, let's compare. We've got x squared on the top and an x on the bottom, and x to the third on the top and an x squared on the bottom. It looks like this top has a bigger exponent than the bottom, doesn't it? And this one too. Okay. That's probably going to be the clue there. The bigger exponent is on the top, so then it's none. Okay, let's look at 5, 6, and 7. They have a bigger exponent where? On the bottom. And you got y equals 0 for that one? Okay, what about number 5? It has a bigger exponent down here. You get y equals 0. Now number 6 has the same exponent. And you got y equals what? 5 over 2, which is 2.5. Okay. Okay, so what we're discovering there is a pattern here. Okay. And it says, is there any way to tell the location of the horizontal asymptote just by looking at the functions? Yes, there is. We don't have to look at the tables to find a horizontal asymptote. Okay, so those of you that have your notes, does everybody have their notes out? Because we're going to do the trick for finding horizontal asymptotes in your notes. You just kind of discovered it. Now we're going to summarize it. And then we're going to take some problems and find them. Find the horizontal asymptote. Okay, So the trick for finding horizontal asymptotes is we first look at the exponents. And you find the greatest exponent used in the numerator and in the denominator. In each, the greatest exponent is called the degree. We're looking at the degree of the numerator and the degree of the denominator, and those are your exponents. Okay, then there are three possibilities. The three possibilities are a number, y equals 0, or none. Okay. So in this first one, if the degree of the numerator is greater, and I always think of numerator, greater, numerator, none. Okay. If the degree of the numerator is greater, there is no horizontal asymptote. There's no limit. The table showed us, that there wasn't a limit. Okay, if the degree of the numerator and the denominator are the same, that's when you take the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, and if the degree of the denominator is greater than y equals 0. So now we're going to look at some examples and apply this to these functions. Okay, so we're looking for the degree of the numerator. What's the degree of this numerator?
X squared.
Well, it would be actually the 2. But you're right, we're kind of looking at the x squared. We're looking at the highest exponent. What about the degree of the denominator?
3.
Two.
Oh, it's the greatest.
Yeah, you just look at the greatest one, okay? The greatest exponent, highest exponent. So are they the same? So then we take the numbers in front, the coefficients. So the y would equal 3/5. And it's y equals because it's a horizontal asymptote going through the y-axis, okay, at 3/5. All right, then how about the next one? Degree of the numerator is?
2.
And the denominator?
1.
Okay, and the numerator is greater. So numerator, none. This does not have a horizontal asymptote. It actually has a slant asymptote. If it doesn't have a horizontal, it has a slant. We're not going to find the slant asymptotes this year. We'll do that next year.
What does that look like in graph?
It looks funny. Okay, it looks something like if this was the slant asymptote and that was the vertical asymptote, it looks like this. Okay. You will have a vertical asymptote, but you just won't have a horizontal. You can only have a horizontal or a slant, not both. Okay, then the degree, this next one. What's the degree of the numerator?
1.
And denominator? So now the denominator is greater. And what's the horizontal asymptote?
0.
0. You just have to memorize this pretty much. Okay, how about these? 3 and 3, and they are the same. So what is the horizontal asymptote?
2.
Good. 4 divided by 2, which is 2. Okay, eventually we're going to put that in our journal. We're going to practice finding horizontal asymptotes, vertical asymptotes, and the domain. Thursday we did the domain and the vertical asymptote. Now all we're doing is adding them on